All right, guys, we're gonna jump into 8.3. Um, I would call this one a very interesting section. It's not really that important for us, but if you can imagine, this has a lot of usefulness in other courses, whether math or physics or engineering. So the section that we're doing is called trig substitution. And for most of these in chapter 8, I'm not really going to refer to the book. I did in the last video just to show you guys where that formula comes from. I would not, I would not ignore the book, right? I would definitely look at what I'm going over in my help. Okay, so let's jump in to 8.3. The first question is asking you to recall half angle formulas. So do you remember these? You may or may not. Okay, so you can Google these. And as we go through this stuff, I would just bear in mind that um, um, you're gonna need these at some point, right? This is not, they're not just telling us this to tell us, okay? Um, so you may or may not know sine squared, and you're gonna need this, and make sure you know this one is this, right? But that's not half angle, that's Pythagorean identity. And you're gonna need to know this one, right? Vice versa. But the one they're referring to, and I don't have all this memorized, so don't beat yourself up. This is cos 2x over 2. And what about sine squared? Well, you could see, right? If cosine squared is this and sine squared is this, then we could say it's 1 minus this one, right? So make sure you have this handy. And that would simplify to half minus cos 2x over 2. Right? Let's put all over 2. All right, so that's sine squared x. Okay, so that's what it wants here. First question. Okay. Also, guys, if you watched the last video, I ended up deleting question 11. It's a funky problem I've never seen before. It's not that I couldn't do it. It's one of those problems, and I find this a lot in math, where authors or teachers will give you questions that are so particular that you couldn't just sit there and do it on your own. Now, as we're learning this, that's going to be the case for most things, but I don't want to just give you guys stuff to have you do them, right? That's a waste. I want stuff to connect. And so as we go along, especially in this chapter, when and if we encounter problems that are very different than others, we will try to not do them. Okay. So, all right. This is a really good question. So I want you to focus on question 2, because what we're going to do in this problem is going to tie into the rest of this section. What they're asking is, do you see something about this? Now, yeah, you see, okay, it's sine cubed. That's great. Or that's sine cubed. That's not what I want. We want sine squared. And that's sort of the observation is, if this was a sine squared instead of cubed, we could write sine squared as 1 minus cos squared. But we don't have that, right? We have a cubed. So what we're imagining here is 3 things, right? Sine cubed is sine times sine times sine times sine, right? But if you notice, if we write it that way, that's actually sine squared times sine. And then we have the Pythagorean identity here, so we can rewrite sine squared as 1 minus cosine squared times sine. Okay? So that's that one. Now, why did we do that? Because for this problem in particular, we can apply that same idea, right? We can say, well, let's pull that 3 out. Why not? You say, well, man, if this was cos squared, we'd have something. Okay. So watch what we do. We're going to write cos cubed as cos squared times cos, and then apply the Pythagorean identity, and you'll see why. Oop, like that. Now, what's going to happen is I'll erase this part. Um, what's going to happen is we can write this as 2 to cos x minus 3 sine squared x cos x dx. Okay. And with that, we see, okay, this is pretty easy, right? What's the antiderivative of 3 cos x? That's 3 sine x. And this is actually, believe it or not, a u sub. So we'd let u be sine x, and then du would be cos x. So we have minus 3 antiderivative u squared du. And again, we can integrate that. We get u cubed over 3. And so the final answer would be 3. You guys have help for this one, so you can follow. 3 sine x minus u cubed, but u sine cubed x. That's close. Okay, so that part is this. If you do that, you'll get that. So make sure you're trying these. Okay. Okay, integrate the given function. This is where we want to apply the half angle formula. Okay, we can't say we could, but we're not going to. We don't want to do this, right? That's true, but it doesn't really get us anywhere. If you recall from problem 1 or 2, we said sine squared is the same as 1 minus cos 2x over 2. And when we don't have exponents in the trig part, it's somewhat easy to integrate. So what we're going to do is we're going to say 3, but instead of sine squared, we have this. And, oh, why did I put that squared? It's a 2x. That. And we can do that one, okay? It's not that hard. Okay, so maybe we write it as 2 integrals. We say 3 half minus 3 antiderivative cosine 2x over 2. And this is just a u sub for u is 2x. So make sure, if you're trying to do this problem, make sure you can do this one. Okay. All right. So you're laughing. I got this wrong. I rushed through this, guys. I didn't think about something, but let me show you this one. So we have 5 sines, right? So what can we do here? We could do this. We could say, this is a little complicated, but this should come to you, right? It shouldn't seem as difficult as, say, integration by parts. So the first thing we want to say is, well, this is like sine to the 4th times sine. Okay, that's true, right? And then we can say sine to the 4th is sine squared times sine squared, and then times this sine, right? So we still have sine to the 5th. Sorry, this is 2x, but I'll leave the 2 out for now. And then what we want to do is say, well, sine squared is this. And sine squared is this. Why? Because if we say cos of x is u, then sine is the du, right? So what we really have is 1 minus u squared. So try to see this. Don't think, see it. Times du. Okay, this is what we have here. Okay. And if you FOIL that out, you would get some integral that looks like this. And we can integrate that. Okay, that's just u to the 5th over 5 plus 2 2/3 u cubed plus u And then I substitute back what I picked for you, which was cos. Okay, so it becomes cos to the fifth with 5 cos cubed plus cos. Okay, so that's the idea. Now, when we have that 2x there, it's a little annoying, but it's still gonna work out pretty nicely. Okay. Okay, so again, I'm just showing these to you guys. I don't expect this to be comprehensive. That's what my student hours should be utilized for. Some of you guys come to them, some don't. Um, I'd like to see you there. But anyways, what do we do here? Well, we say, and again, you're like, how do you see this? It's just from practice. I'm not Einstein here, right? This is the first thing you want to do. I'm just going to sort of tell you how to think about this. Say, okay, what's going on? What's going on? Well, the idea is we want to see either sine as du. So let me write this down. You want to see sine as du. Oops, sine is sin, or cos as du. Okay, that's the connection, right? What's the derivative of sine? It's cosine. What's the derivative of cosine? Sine, right? And so we know that if we pick one as u, then our du is the other one. Okay, now this is negative. Okay. So what I do is I say, hey, I can see that. I could write sine cubed as sine squared. And I'm actually going to show you guys sort of the motion to this. And I could move it like this, right? Sine squared, cos squared sine. And then I say, okay, that's almost good, right? This is the whole thing is that's du, right? Because it's the only one without the power in the exponent, right? It's just sine to the power 1. So then if this is du, that tells me I want cosine to be u, and I have cosine squared. This thing has to be changed. So how do we change sine squared into cos or cos squared? We write it using Pythagorean identity and write it as 1 minus cos squared times cos squared times sine. And you can see that that looks like, I'll just write it here. It's like 1 minus u squared times u squared times du. So that's what we're doing. It's sort of a u sub. Okay. It's tricky. It's tricky. Okay. And then you integrate each one. So, but I think you guys will get it. Oh, what do we do here? We have sine. Well, we don't panic, number one. We say, well, the good thing is they both have 5x. That's good. Now, what do we do? We do this. Well, you hit view an example, but we want to be able to think of this, right? So what does this problem lend? You say this. Okay, you say cos cubed, that's like cos squared times cos, right? And then we have this weird sine -2. Now you might think, hey, if I had, what's the opposite of this? The opposite would be sine squared. And so we can sort of get that, right? We can say cos squared is 1 minus sine squared times this times this. So that when these two multiply, that cancels. So we'll still have this. Okay. And then what do we do? That's still going to be sort of a u, right? What's another way to write sine to the -2? So you think about it. And it's a little funky. So maybe I'll walk you through the viewing example. Let's see what they do. Okay. They're using a rule, which is sort of what we just applied, and they did the same thing. So if you see and view an example, it's the step we just did. Oop, why is this not writing? They wrote it like that, okay? And then let's go a step further. No, it's not going a step further. And you can see, where do they do it? That these two cancel. Okay, so this cancels with that, and we're left with this. So let's look at that, because that's kind of where we were. Cos sine -2 minus this cos, but this one's easy. So what we're really looking for is how are they going to do that? Okay, so let's see what they do. Okay, they split into two integrals, but we know that. We already did that. And they say, so the writing threw me off a little, but when you have sine squared or sine negative, that's the same as writing it in the denominator. Um, and this is a u sub, right? My u is sine and my du is cos. Okay, so that's what they'll do next. I'll just walk through the rest of the help, but nothing crazy here, right? Um, they wrote it like that, but you don't need to. You could just think of it as a u sub. I don't know why they went that way, but anyways, a couple more to do. We got evaluating the 5 sine squared cos squared. How could we do this one? What could we do? All right. You might say, well, we know this. We know sine squared is 1 minus cos squared, but that might not get us anywhere, right? You can kind of imagine, does that help us? Not really. What if we wrote cos squared of sine as 1 minus sine squared? It's not really going to help us either. So what's the workaround? We could just click help, but we don't want to just do that. We also know from question 1 that we could use half angle, right? We said sine squared was this, cos squared is this, okay? So that might work, it might not. But you just have to play with these guys and see what happens, right? We will have the sort of a double angle. So let's see. If we did that, I guess we can just do it. If we FOIL this out, we have this, and you can see its difference. So it would be cos 2x squared plus a quarter, and this is over 4, and it's a negative, okay? And then let's see, what can we do there? Well, if you look carefully, you see that this is 1/4 times, see, 1 minus cos 2x squared. And you can break this down. So you can do another substitution using half angle. Okay, just like we did, except we have 2 there. So this becomes, I hope this helps a little. This becomes 1/4 times 1 minus, the substitution would be 1 plus cos. Now this becomes a 4 because we double it over 2. So this is a trig problem, but this whole section's trig. So it is what it is. And then we'd have 1/4 minus 1/8 plus cos 4x over 8. This is a negative, sorry. And these simplify. This is simple. That's just negative, or no, sorry, positive derivative of an eighth Minus antiderivative cosine 4x over 8. And that's just a u sub. Okay. I'll show you guys this one because you're probably like, show us it, show us it. So you can check the help though. But just doing that last part, um, my u is cos, oh, sorry, my u is 4x, so my du is 4 dx. And I move that over, so it becomes du over 4 is dx. So we have negative 1/32 cosine u, which is negative 1/32 sine u, and my u is 4x. So it's negative 1/32 sine 4x. Okay. And do the next one. Anyways, that's a hard problem, right? It doesn't come to you. You can click on help, but I want you guys to at least try these so that you're thinking like, how would I solve this if I saw this on a test? Don't just automatically go to the help and be like, ah, help me. All right, a couple more. Now you can watch the video, it's fine. You can refer to the textbook. I'd highly recommend that so you have some sort of reference point. But to me, when I see this, let's see. If I wrote, because this is the smaller one, what would that be? Well, hmm, again, you're gonna have to play with these. You could say I have sine squared and sine times cos to the 7th. And then I can say I have 2, like change this to 1 minus cos squared times sine times cos to the 7th. And then how I think about that is cos is u because this is the one that has the 1 power. So that's going to be my du. So I really think about this as 1 minus u squared u to the 7th du, and this is a calc 1 integral, right? This is just u to the 7th minus u to the 9th du. So you just add 1 to and divide by the new exponent, substitute back for u. Okay. So I think I got rid of the last few problems. I think you guys could have done these. They were doing tan and secant, but it's the same thing, right? There's no point in saying, hey, okay, sick of sine and cos, try tan and secant. No, you're gonna be more sick of them. So I got rid of the last three here, but if you guys have any questions on this section, do let me know.